You know, there's a lot of tables in the code book, and a lot of them are commonly used, and probably most of them are rarely used. In a given journeyman exam or master exam, there's a few tables, however, that are predominantly used. One of those tables is table 220.54, and I'd like to talk to you real quick about that table. It is a dryer table strictly for residential dwellings, and if you'll look in your code book, I'm in the 2014 NEC edition. On page 71, you'll see a table, actually a pair of tables on that page. If you'll just take a quick minute to turn there. Okay, so the two tables that you see on page 71, the one that's on the left-hand side is on the inside of the page is the 220.54. That is the dryer table. This is part of the standard method of calculating residential dwellings. It is not part of the optional method, so there are some different calculations that you might run across on an exam or even in the real application of the table that might differ a little bit from what you're going to learn here. However, predominantly, we use the standard method of calculating a residential dwelling under parts 3 of 220, or Article 220. Okay, so 220.54, let's look at this table real quick. You'll notice that the table in your book looks very similar to this, where you've got a demand factor, you've got a number of dryers that is listed on the left-hand column there. At the top, it's labeled 220.54, demand factors for household electric clothes dryers. All right, to begin with, the number one thing to remember about this table is that you cannot use this table for commercial dryers. This is strictly for residential dwellings. It can't be used in a commercial setting. The only time that there's some gray area or some common areas that it might be used in a commercial sort of setting would be an apartment complex, where I've got a central location for all of my guests or my occupants to do their laundry collectively in a laundry area or in some sort of a washateria or something like that. In that case, since the occupancy type is still primarily a residential dwelling, then we would be permitted to use this table in that case. All right. Now, I've done a couple of notes down here at the bottom. You just kind of ignore those for a minute. Looking at the table that you're seeing on page 71 of your code book, you'll see that 1 through 4 dryers, there is a demand factor listed on the right-hand side there of 100%. What you're looking at on all of those demand factor percentages, those are multipliers, so they are factors to be used as a multiplication step. So, for example, if I was trying to do a dryer that was 1 through 4, 100% of the demand factor. Let me pull up my whiteboard here. If I had a dryer that was sized as 6,500 watts, sorry for the skew in the writing there, this would be considered a nameplate rating. So some manufacturer put together this dryer, and in a laboratory setting, with every one of its components maxed out at 100% of its possible output, they came up with 6,500 watts of total workload that this dryer is capable of producing. Now, rarely is that the case. Sometimes with especially, for example, electric cooktops and ranges and that sort of thing, typically the actual usage of it in everyday normal life is going to vary so vastly from what the laboratory number would be. However, with dryers, it sometimes can be the actual nameplate because there's not that many components to them, so they're either on or they're not, but you've got your tumbler motor and your heating units on the inside that basically take up the majority of that wattage output. And at any rate, so 6,500 watts. If I have one dryer, I'm going to multiply that times a factor of 100%. So to turn that into a multiplier, I would put my decimal 2 places over to the left, and that would be 6,500 times 1, basically. Okay? Now, if we had 6,500 watt dryers and there were 5 of them, I'll just make it easy math. Let's do 5,000 watts because that's a little easier number to deal with. So 5,000 watt dryers. and we had 5 separate dryers, right? We would be looking at a combined nameplate rating, equipment manufacturer rating of 25,000 total watts, because I would just take the 5,000 watts, multiply it times 5, and that would give me 25,000, or if I was doing it as KW, I could just do it like this, where I'm doing that number there as a kVA value, so it'd be 25 kVA at that point. Okay, so you get the idea. Now the multiplier that we would have from the table for 5 dryers, if you go back and look at that table real quick, is 85% is what that would be. So we would be going back to, sorry for the blip there, we'd go back to this and we would multiply this 25,000 watts. Now let me go back and make this, just leave it as watts, keep it from being confusing. Now it is interesting to know that on this test, or when it comes to calculating specifically electric dryers in a residential setting or electric cooking units, ranges, ovens, things of that nature, the code actually does specifically tell us that a watt and a volt amp is the same thing. So we can use those interchangeably in this kind of appliance setting. So 25,000. Again, I said I was going to use watts, so let's just use watts there just to stay with convention. All right, 25,000 watts. I would multiply times the demand factor. In this case, that 85% that you see on the table is a multiplier, so I'd put that in my calculator as 0.85. All right, that would give me, let me pull my calculator real quick, 25,000 times 0.85, and that would give me 21,250 as a final number there, 21,250. Now, once we've done a multiplier, right, a factor, a demand factor, which that's what this is right here. That's an important process or component of the process. This number here, this 5,000 watts that we're talking about, again, is a manufacturer's nameplate or basically an equipment rating. This is the process that we would normally take the demand factor that would move this connected load to a demand load. And this would actually be what we would expect to see in an actual application basis. And with dryers, if we have 1 or 2 of them, it might be that they're both running at the same time. But as we add more units to the same service with dryers, you would expect to see dryers in use at different times, different start times, different run times. So the diversification of the load kind of lessens that we don't worry about calculating the full 100% any longer. That's why you'll notice on this table it continues to get smaller as you go down. All right, so let me go back to this table real quick, because there are a couple of things I want to point out to you real fast before we go any further. And that is, I'll go back to this table so I can pull it back up. All right, when we're looking at these figures here, a lot of electricians don't realize that tables in the code book come with an article that has the exact same numbering system on it. So for example, this table is listed as table 220.54. Now, somewhere in your code book, there's a corresponding article for that same table that oftentimes tells you exactly how you're supposed to use that table or what the rules are as far as how to apply the table. In this case, there is a really important rule that if you don't pay attention to the article, the instructions to the table, basically, you could get yourself in trouble and be using the table in a manner that it wasn't intended to be used. All right, so let's look at the actual article then that has 220.54 as its numbering system there. So if you look on page 70 of your code book, down at the bottom right-hand corner, you'll see it kind of as the last article, the last paragraph down in the bottom right-hand column. And it says 220.54, you must use a value of 5,000 watts, nothing less than that, when it comes to calculating dryers. Now that's an important note because, let me pull my annotation up here, because when we're doing the application of this table, let's just say that, for example, I had a dryer that was rated for 4,500 watts, right? Come down here so I can. So 4,500 watts as a nameplate, or let's just call it connected load, whichever term you prefer. Okay. I can't look at this dryer as having a value of 4,500 watts because of the rule that the article says that states I have to use either 5,000 watts or the nameplate of the dryer, whichever's larger. Okay, in this case, the 5,000 watts from the actual code instructions would tell us, or the article instructions would be, we'd have to bump that up to 5,000 total watts before we do any of the application of the demand factors of the table. If I were to have had 4,500 watt dryers like this, and I had 5 of them, as we did as an example a minute ago, but there we were given that the nameplates were 5,000 watts. If I had 4,500 watts and I had 5 of those, each one of those would have to be bumped up to at least 5,000 watts prior to doing the math, and of course the math would then roll back out the exact same way. It'd be 5 dryers, 5,000 watts each, 25,000 watts, 85% derating factor, 21,250 is a total demand load for the feeders on the service for those 5 dryers. Now, granted, I have a hard time understanding why this table has so many dryers listed on it, because I can't imagine too many instances or circumstances where you would see 41 dryers all on the same set of feeders. Be that as it may, on an exam, you sometimes guys will, or I say guys, exam writers will come up with some of the most bizarre conceivable set of circumstances to write an exam question about, just to basically prove that they know the table well and that you don't, and just trying to, I don't know, make it a little more complicated than it needs to be. And it's certainly not something that a lot of times has any useful field application to it. But I do want to go through the rest of this table, even though I don't think you'll ever professionally use it in your career. And correct me if I'm wrong, I'm sure some of you guys have probably done, again, like a residential dwelling as a load calculation. Keep in mind, this table is not a branch circuit calculation. It is a feeder calculation. So what we're doing with these numbers here, we're not trying to divide just this number itself by 240 volts and determine the ampacity to run a couple of branch circuits, Romex and breakers on it. What we're trying to do is figure out just on the feeders on the surface of the building, just what this part of the load represents, so that we can take this number and then add it along with all of the other calculations that we would have to calculate the service for that dwelling occupancy type. All right, so kind of got off track a little bit there, but let's go back and look at the table now. So it's real self-explanatory. All of these right here are going to be demand factors. And you can see that they take a couple of jumps to go from 185, it's 15 points there, and then 10 points, and then 10 points, and then 5 points, 5 points, 5 points, and 3 points. So it gets to be a little bit less of a separation between the demand factors as you go down the list there. Once you go past 11, though, the table kind of stops. And basically what I want to point out here is that this table, for lack of a better way of describing it, just got lazy is what it boils down to. If you look at number 11 there, the 11th dryer, they're telling you that if you had 11 dryers in a residential dwelling, then I would take the nameplates of all of them, multiply it times 11. Again, if we were using 5,000, then it'd be 55,000 total watts, times 5,000 watts, or the nameplate. If the nameplate's larger, I would use a larger value. 5,000, though, would be my minimum value that I could ever use. So let's say I have 11 dryers, 5,000 watts each dryer would be 55,000 total watts, and then I would multiply that total by 0.47 on my calculator, and that would be the demand load that I would have for 11 dryers. Okay, that's easy enough. All right, not too complicated. Now, what happens though, rather than taking a really long length of text or space in the code book, basically they got lazy and said, okay, if you can understand that at 11 dryers, we would have a remaining demand factor of 47%, and that's what this last row here is, then we're just going to lump sum the next 12 steps, or excuse me, 11 continue, it'd be 12 additional dryers past that, but you have to do your own manipulation of your demand factor yourself. So let me see if I can make that make a little bit more sense. Hope I didn't lose you there. All right, 11 dryers is 47% demand factor, following along with the table. And then at 12 dryers, what happens is that every dryer past 11, I'm going to lose 1% of that demand factor from the 47%, which is what the row stops at on row 11 there. So for example, I'm looking at row 47 here, and I've got 47% minus 1% if I had a 12th dryer. So makes sense that if you look down here at this little type that I've got, the 12th dryer would be rated at 46%. I'm going to take 1% for each dryer that exceeds 11. So rather than, sorry, again, my drawing skills are not necessarily the greatest in the world. I'm trying to learn this new tablet. See if I can do this better. 1% for every dryer that exceeds 11. So that makes sense. If you look down here as we go down this list that I've got typed up here, I've actually got all the way from 12 through 23, which is what that line up there represents. So I would have the last one at 11 would be 47%. The 12th one, I'm going to lose a percent, which is the 46, 45, 44, 43, 42, 41, 40, 39, 38, 37, 36, and then 35 as the last value. So you can see that we just took a 1% step all the way down that list there. So at the 23rd dryer, we would have had a calculated or new sub-calculated demand factor of 35%. So then if we go back and look at the table again, you'll notice that the next row starts right after that. So I'm looking at 35% now. But now instead of 1%, I'm going to use 0.5% for each dryer that exceeds 23. So my 24th dryer would lose percentages like we've done so far, but now it would only lose 0.5%. So if my 23rd dryer was 35%, my 24th dryer would be 34.5%. And then my 25th dryer would be 34%, and it'd be 0.5% off on each one going down the list. And if you have 43 and over, that'd be 25%. That's the last row there. All right, let me do an example because I probably lost quite a few of you there. And again, I'm trying not to overcomplicate it, but this is not this table doesn't really make a whole lot of sense, I don't think, initially when guys look at it. Certainly didn't to me when I first looked at it. All right, let's start out with a real simple example. Let's say that we had a very simple set of dryers, 5 of them, each rated for 4,000 watts. Remember, the article tells us that we can't use a value less than 5,000 watts or the nameplate of the actual dryer itself, whichever's larger. In this case, the 4,000 is not big enough, won't cut it. So I'm going to have to get rid of this number, if that was the nameplate of that dryer, and bump that up to 5,000 watts minimum from that table, excuse me, the article. And I would just write myself a note, guys. If I were you, I would just put minimum 5,000 watts right on the top of the table that's on page 71. That way you don't have to worry about remembering or keeping track of it. It'll be right there on top of the table when you go to use it later on if you do. Okay? All right, 5 times 5,000, since there's 5 of them, 25,000. The demand factor for 5 dryers is 85%. It's given to you right there on the table. All right, let's say that we had a set of dryers that were, we'll just say we had 28 dryers. 28 dryers. And just to make it easy, let's just say that each nameplate was rated for 5,500 watts. Now, what happens here is that because I use 5,000 as a minimum number or the nameplate, whichever's larger, I'm going to be using this 5,500 watts, not 5,000 watts in this case, okay? All right, so what the code book tells me is that every dryer out of this 28 that's past 11, because remember the 11th dryer, I basically had a demand factor of 47%. So what I would do is I would subtract 11 dryers, and again, this is because that's what the table stops at on the 11th dryer, right? Subtract 11 dryers from that number, and that would give me a total of 17 dryers that went past the initial block of 11 that I would have a demand factor of 47% if that's the only number of them that I had. But since I had 17 more that went past that row, I would have to subtract 1% for each one of those 17 dryers times 1%. So that would effectively give me a 17% reduction in that row that was the 11th dryer at 47%. I would just subtract those two numbers there, and that would give me 30% as a new calculated demand factor for that block of dryers. Okay, not done yet though. I have to do that math to find out what my demand factor is. So then I would go back to this 5,500 watts here. I would multiply 28 dryers, because that's how many I've got, times 5,500 watts. And then I would multiply that entire connected load or nameplate rating or equipment manufacturer rating at a demand factor of 30% times 0.30. And that 0.30 again comes from this math that we had to do up here, where we had to calculate our own total demand factor from the table. Okay, just to give you a complete answer there, let me just do it real fast. That would be a total, and if you have calculating, do it with me as you're doing it there at your home. So 5,500 watts per dryer, I would have a total of 28. That would give me a connected load of 154,000 total watts. So I would have 154 times 30%. And times 30%. And that would give me 46,200. And a lot of times on an exam, they're going to give this number to you in a kVA value. So even though we calculate that out as a number, that is 40,000. I can't get my calculator to move. 46,200. So 46,200 is what we ended up with. 46,200 watts or volt amps. Typically, after we do the demand factor, we convert that or call that number, the demand load itself, a volt amp value. Again, in the case of residential dryers and ranges, it's interchangeable. So if they try to confuse you on an exam or something of that nature, don't let them. It's just silly nonsense. All right, so 46.20 kVA would be the shorthand version of that, expressed in thousands. So we've got basically where the comma is, we put a decimal, we drop the last digit and put a K in front of it. Simple as that. Okay? All right, I hope that helps you a little bit. If you guys have any questions, don't hesitate to make a comment down at the bottom of the screen. Sorry for the quality of the video, but I just wanted to start doing a few of these tables one at a time, put them out there for you. Hopefully that'll help you kind of make some sense of some of these tables. And we'll be producing more of these tables, these videos that are specific to just one table over the course of the next 6 months. Please subscribe to our channel.